Okay, so in this learning target 2, we're going to talk about how to take a situation and to find a function that fits it. So basically how to write an equation for any real world scenario. And we did a little bit of this in algebra, but you didn't specifically learn how to do it based off of information given you. So basically we're going to fill out this in a second, but let me talk you through it and then you can pause and fill in the blanks. So basically, if an object is rising and falling under the influence of gravity, so basically this is usually called projectile motion because it's usually something that's thrown or catapulted, or basically it's a projectile. It's going up in the air and coming back down without any additional forces on it. And so you can use a quadratic to represent that because it will happen in the shape of a parabola. And it's important to know that we're going to represent the time in seconds. That's going to be x, so the time in seconds since when it was thrown or whatever. And then y is the object's height from the ground. So we're looking at the height in the ground, and we are going to do this in meters or in feet. Okay. So the coefficient, the leading coefficient A, is always given by the downward acceleration due to gravity. This is negative 4.9 if it's in meters, and negative 16 if it's being measured in feet. So these are two numbers you're going to need to memorize. The middle coefficient, the coefficient in front of x, is the initial upward velocity of an object. So this usually is given to you or can be found. We're not going to get into that too much. That's more physics. But in our scenarios, it's going to mostly be, if we're going to be writing it in general form, it's going to be given to you. Otherwise, you might start with a different form and then convert it like we've done in the past. And then the last term right here, sometimes if we're looking at it in general form, so if it doesn't have these coefficients with the velocity and S sub 0, the initial height, you'd see that as C. So this last term, the constant, is the initial height of the object. So this is, this term right here is, if you think about it, it's the y-intercept because it's the height of the object when the time is at 0. Okay, so we already knew that part of it. Now you know what A and B stand for. So go ahead and pause it if you need to, get all those gaps filled in, and then we're going to start an example. So in this example, this is about Julie. Julie jumps in the air. She leaves the ground at 0.25 seconds and lands at 0.83 seconds. So we don't actually know the technical intercept because as you can see, she doesn't leave the ground at time 0. Okay, so our intercept is actually going to be down here somewhere eventually. Okay, and it's not going to be, in this scenario, it's not actually going to be realistic to think about that point because obviously you can't be at a negative height, but it still exists. That intercept, at least, still exists. But what we do know is we do know the roots, and the question is asking us how high did she jump in feet. So what we need to find, this time is the vertex, because they're asking for basically the maximum height. The vertex is the maximum height that we reach. We know the roots. We're talking in seconds, which is good. If the information were to be given to you in a different measurement, you'd want to convert it to seconds. So if it gave it to you in minutes, you might change it to seconds. And then this is talking about in feet. So we know that the leading coefficient, because it's given to us in feet, will be negative 16 feet per second squared, because that is the downward acceleration due to gravity. So that's never going to change. So in this one, if I'm talking about factored form, and I don't remember exactly what the letters are that we've used, but something like this, we can just plug in negative 16 and then x minus 0.25 and x minus 0.83. Those are our roots. And then what we need to do is find the vertex. So what we've done in the past is we've averaged these two numbers to find the middle. That would be our x value. So let's go ahead and do that. Oh, look, 2 months and 1 week till my wedding. Got my little countdown going here. Okay, so I would take 0.25 plus 0.83 divided by 2, 0.54. Let me double check my work just to make sure that matches. Yep, okay, so 0.54 is the x value of our vertex. So I know in this point, 0.54 is the x. And then because we have a function, and this is something that you did in some of those focus problems in the last section, is if you know any x value and you know the equation, even though this is in factored form, not vertex form, I can plug that value for x into the equation and I can find my y. Hang on, my phone's ringing. Let me pause here. Okay, sorry about that. So I'm going to plug 0.54 into my equation. And if you're using the, especially if you're using the Inspire, you could just type this in as is, but basically what you'd do is you'd subtract this, and then you'd multiply negative 16 times the answer here times the answer here. I'm just going to go ahead and write down it's approximately 1.35. So this is your answer here. This is the y coordinate of the vertex, which is the height in feet at 0.54 seconds. That vertex is the maximum height that she jumped. Okay? Okay, so in this one, Nora hits a softball straight up at a speed of 120 feet per second. If her bat contacts the ball at a height of 3 feet above the ground, how high does the ball travel? When does the ball reach its maximum height? So I find it really helpful to draw a picture of this situation. So I'm looking at seconds here, and this time I'm looking at feet. Oops, seconds. And then we do have a height of 3 feet above the ground when her bat hits the ball. So I know here is 3, and then I know that the ball will go up in the air, meet its maximum height, and then come back down, okay? And then obviously there's a second root over here somewhere, but we don't really need to know that one, and that one really doesn't apply in this particular situation. So this time I know the initial upward velocity is 120. I know her height was 3 feet, and since it's measured in feet, I still know the leading coefficient. So I can go ahead and right away write the equation negative 16x squared plus 120x plus 3. Because of our notes that we took at the beginning, I've got my downward acceleration due to gravity, my initial velocity, and my initial height. Okay? So the question is asking how high does the ball travel and when does the ball reach its maximum height? So in the past, when it looks like we're actually finding the vertex again, and in the past we've tried to average the roots, but we don't know the roots. And so I wanted to give you this quick tip about how to find the x value of the vertex quickly. The formula for that is negative b over 2a. So if I wanted to find the vertex, all I need is these a, b, and c coefficients. I don't even need c, just a and b, the gravity and initial velocity. So I'm going to do negative 120 over 2 times negative 16. That negative is out in front, so that means we'll evaluate this inside part and then take the opposite. Okay, so I'll do 120 divided by negative 32. So I'm going to end up, I can tell here I'm going to end up with a positive answer. And let me look at my work here. I should get 3.75. Okay, so that is my x value of the vertex. So that means that I already know that at 3.75 seconds it's at its maximum height. So I actually already got this answer. When does the ball reach its maximum height? So I can start my answer here at 3.75 seconds. And then I can just plug that in. And I will get approximately 228. Okay, so the ball at 3.75 seconds, the ball is approximately 228 feet high. And that's the maximum height, okay? So you might want to think about a couple things to memorize. Is you need to memorize what A, B, and C stand for. So the downward acceleration to gravity, the initial velocity, and the starting height. You need to memorize the -16 and -4.9, those downward acceleration due to gravity in feet and meters. And then I would also memorize this vertex here, the formula to find the x value of the vertex. You could always go through and you could find the roots using the quadratic formula, and then you could average those to also find this number, but this is just a quicker way to do it if you don't know the roots. Okay? So I actually don't have any problems for you to work on before class, but you'll just be working on some problems in class on this one.